This is 4.2, the unit circle. Our objectives today are to know how to identify the unit circle and its important pieces. We will be having a quiz next week on all of the important pieces to the unit circle. I just handed out a unit circle worksheet that you'll be completing over the weekend. The second thing is knowing how to evaluate using the unit circle to find the 6 trig functions. So the first thing is, do you remember these things from 4.1 and 4.3? What is radian measure? What is degree measure? SOHCAHTOA from right triangle trig. And cosecant, secant, and cotangent. Don't need to write any of those down. Make sure you know what those are. And then we'll be having a quiz after section 4.4, so later next week. All right, this is what I do want you to start to write down. The unit circle is very important to know as you move through this class and on to next year for calculus. When you walk into calculus, you need to have memorized all the important pieces of the unit circle. It is imperative that you know that. So if you had FST, your teacher probably gave you the same exact quiz that I'm going to give you next week on the unit circle. So the unit circle is the radius of 1. And it's given by the equation of a circle. X squared plus y squared equals 1. Sure. We don't have enough time to go out and derive where all of these points came from on the unit circle. Where it came from is x squared plus y squared equals 1, which is the equation of a circle, where the center of the circle is 0, 0, and then the radius is 1. Does that equation look familiar to you in geometry, the equation of a circle? X squared plus y squared equals 1. And then what they do to find these ordered pairs, they use the Pythagorean theorem. A squared plus b squared equals c squared. So if I were to find what this ordered pair is on the unit circle, I would drop down a right triangle. That red is always 1, and then I'd want to find the distance here and the distance there using the Pythagorean theorem. We're not going to spend the time doing that. But there are some very popular right triangles that we learned about in geometry. They're called the special right triangles. And I'm just going to show them to you. You don't have to write them down. They look like this. The 45, 45, and then the 30, 60, 90. Do you remember these two? We focused on them. We found the missing sides. We kind of taught you a little trick on how to remember them on those sides. And they're going to fall into play. This 45, this 30, this 60, this 90 on the unit circle. So that's why we introduce it back in geometry. All right, so moving back to the unit circle. When we use the unit circle, it allows us to find the 6 trig functions. The sine, the cosine, the tangent, the big 3, and its inverses. The 2 important pieces from the unit circle that we're going to take from it is the x and the y. The x value, the ordered pair on the x value of the circle, is going to represent the cosine of this angle theta. So we call that the x piece. The y value on the ordered pair of this circle, the unit circle, is the sine of that trig function. So when we were doing SOHCAHTOA before with right triangle trig, now we're talking circular trig. They're different. So that is the y value of the point. Then the tangent is not on the unit circle, but it can be found using the unit circle. And how you do that, it is by taking the sine of theta over the cosine of the theta, or y over x. If you can remember those three, then the next three are pretty easy. They're just what we did before in right triangle trig. They are just the reciprocals. So this would be 1 over y, 1 over x, and then x over y. The big thing for you to remember is those 2 points are your cosine and your sine. And the way I remember it as a student is this. If I look back at this point, C comes before S in the alphabet, is the way I remembered it in high school. C comes before S in the alphabet, so as you write an ordered pair, it's X then Y. So that's how I remember it. But we tend to write our 6 trig functions as sine, cosine, tangent, cosecant, secant, and cotangent. When we move later in the chapter, we're going to understand why we need to know circular trig when we graph these trig functions. This unit circle goes on infinitely many revolutions around. We talked about that before when we were focusing on degrees measures and angle measures and radians, where sometimes we have an angle bigger than 2 pi or bigger than 180 degrees, or maybe we have negative angles. Those do exist. What these graphs will look like down the road is they will be like sine waves. Like think about the ocean, and they help us with a lot of application problems later on in this chapter. So you have to know this unit circle. What we're going to do is we're going to start to fill out the unit circle and then go back and find some trig functions. So this unit circle is blank. We're not going to spend the time filling in all of it right now. I'm going to start it, and then we're going to have you finish it over the weekend. So I'm going to start with what I call the easy ones, and I want you to fill out yours on your worksheet that you have in front of you. So here is the center of the unit circle. Remember, all of these segments have a radius of 1. So if I think of the first order pair, you don't need to write this on your worksheet. The first order pair that you probably see in your worksheet already filled out is over 1 up 0. Do you agree? Pardon me? Yep, you have all the points. But we have to fill in the angle measures. Yeah, we have to fill in all the angle measures in degrees and in radians. So that's your initial side. So it's 0 degrees, or if I go around 1 revolution, 360. And then I have radians. 0 radians or 2 pi. Remember, that ordered pair represents the cosine and the sine to get you going on the trig functions. So then let's go up to this one, the next easiest. This is over 1 on the x-axis, or over 0 on the x-axis, and then up 1. You have that. What is the angle measure there? 90 degrees, or in radians, 1/2 of a pi. Then we come over to this point. Now we're going left 1 and up 0. So what's that in angle measure? 180 degrees or pi. So we've gone, now we're heading down to the bottom of the circle. We're going over 0, down 1. What's that angle in degrees? 270. 90, 90, 90, 270 degrees. Pi over 2, 2 pi over 2, 3 pi over 2 is the radian measure. And now we're back up to 1 revolution of 360 or 2 pi. Then what I tend to do is the next easiest, when I'm labeling my unit circle, is I do the 45s. So this would be a 45-degree angle. Don't need to write that blue line. Do you agree though?
Yep.
Yep, splitting it in half. So remember the 45, 45, 90 special right triangle? This point right here, you have on your worksheet is square root of 2 over 2. Square root of 2 over 2. It is 45 degrees. Then 45 more is at 90. 45 more. We're now, I gotta do my radians, sorry. 5 or 4. So we have negative square root of 2 over 2. Square root of 2 over 2. And that angle measure in radians and degrees is 35 pi over 4, 2 pi over 4, 3 pi over 4. We come down here. Negative square root of 2 over 2, negative square root of 2 over 2. Everything in this quadrant has to have a negative x and a negative y. So if I just did 3 pi over 4, 4 pi over 4, this would be 5 pi over 4, or 180 degrees plus 45 more is 225. All right, I'm going to go on to now the 30s and the 60s, and then we'll wrap up this video and go on to the problems. This first point here represents 30 degrees, or 1/6 of the pi. What ordered pair is that on your unit circle? Square root of 3 over 2 and 1/2. Again, how these ordered pairs are found is using right triangle trig, Pythagorean, or right triangles, Pythagorean theorem. Then, let's color this one in black. This is your 60 degrees, or 1/3 of a pi. How I remember this one, it's the flip-flop. This is 1/2, and then square root of 3 over 2. What I'm going to have you do over the weekend is complete the rest of that chart. I don't want you to do it now, because we're going to move on to the rest of the lesson. You can check your answers on the last page of your textbook. Once you complete it, try doing it on your own. Fill in all the rest of the angles in degree measure and radian measure. You have the ordered pairs already.